Good morning to one and all. I'm privileged to participate with all the intellectual brains, sophisticated people, and power packed knowledge hub. This video is going to pull up your confidence and also a game changer for everyone who is being trying to solve for really long now. Today's topic is from eigenvalues and eigenvectors. Now in this video we are going to verify Cayley-Hamilton theorem, and here is the problem, that is we have to verify Cayley-Hamilton theorem for the matrix A is equal to 1 minus 2 2 1 2 3 0 minus 1 2, and also we have to find A inverse. So what is this Cayley-Hamilton theorem? The statement states that every square matrix satisfies its characteristic equation. So what is this characteristic equation? See here in the solution, the characteristic equation is nothing but modulus of A minus lambda I is equal to 0. So A is the given matrix minus lambda times of I. I is the identity matrix. So we have to subtract A minus lambda I. So it's very simple. I have subtracted, that is 1 minus lambda. This is minus 2 minus 0. 2 minus 0, this is 1 minus 0, this is 2 minus lambda, 3 minus 0, and 0 minus 0, minus 1 minus 0, and 2 minus lambda. So here it's so simple that from the diagonal elements of the given matrix, if you subtract minus lambda, so the remaining minus 2, 2, 3, and 1, 0, minus 1 are same here. So here, if you find the determinant, we'll be getting the characteristic equation. So let's get started. So here, first of all, I'm taking 1 minus lambda. So this is 1 minus lambda times of. So we have to close this row as well as this column, and we have to make AD minus BC. The formula here is. So here this will be 2 minus lambda whole square minus. So here this is minus 3. So this is going to become plus 3. So from the middle, so we have to take one minus extra. So this is minus of minus plus 2 times of. So now we have to close this row as well as this column. So if I multiply, this will be 1 into 2 minus lambda is 2 minus lambda. This is minus 0. Clear? So this time this is plus 2 times of. Now we have to close this row as well as this column. So this will be minus 1. This is minus 0. Clear? So this is going to become 0, and see, this is 1 minus lambda times of. If I expand it, this will be a square. So this is b square minus 2ab plus 3. Clear? Plus this is 2 times of. This is 2 minus lambda, and this is minus 2 is equal to 0. And see here, this is minus 1 minus lambda. So this is lambda square minus 4 lambda plus 4 plus 3 is 7. So this is 4 plus 3 is 7. So if I multiply, this is 2 into 2, 4 minus this is 2 lambda. This is minus 2 is equal to 0. Clear? And now if I multiply with minus, so this will be lambda square minus 4 lambda plus 7. And if I multiply with minus, so this will be minus lambda cube. Minus into minus plus, this is 4 lambda square. This is minus 7 lambda. So this is 4 minus 2. This is plus 2 minus 2 lambda is equal to 0. Clear? So now see here, there is single minus lambda cube. First of all, I'm writing minus lambda cube. And the next thing is, so we have to find lambda squares. So here is a lambda square, here is a lambda square. So this is going to become plus 5 lambda square. So this is plus 5 lambda square. And the next thing here is we have to find the quotients of lambda. So this is minus 4 lambda, this is minus 7 lambda, this is minus 2 lambda. So this is going to become, see, this is minus 4, 11. This is minus 13. So this is minus 13 lambda. Clear? And the next one here are the constants. This is plus 7. So if you go like this, this is plus 2 and this is plus 9. So this value is plus 9. Clear? So this is our characteristic equation. If I multiply with minus, so this will be lambda cube minus 5 lambda square plus 13 lambda minus 9 is equal to 0. Now according to our Cayley-Hamilton theorem, so this is our characteristic equation. See, remember, this is our characteristic equation. Now the statement of the Cayley-Hamilton theorem states that every square matrix should satisfy this characteristic equation. So if I substitute A in place of lambda, if it is 0, then Cayley-Hamilton theorem is verified. So here is the characteristic equation, that is lambda cube minus 5 lambda square plus 13 lambda minus 9 is equal to 0. So this is the characteristic equation, and in this characteristic equation A should, so I am inserting A here. So here this will be A cube minus 5A square plus 13A minus 9. So I am going to check whether this is going to satisfy the equation or not. So I need A square value. For finding the A square, so it is so simple that A square value is nothing but A into A. So A square value is equal to, what is A value here? This is 1 minus 2, 2. This is 1, 2, 3. And this is 0 minus 1. See here, this is 0 minus 1, 2. So we have to write it for 2 times, that is 1 minus 2, 2. This is 1, 2, 3, and this is 0 minus 1, 2. Clear? So for multiplication, see what I am going to do is, for multiplication, see. So this is our easy way. So these two are the sleeping lines and these are the standing lines. So I am going to multiply this one. So A square value is equal to, so A square value is equal to, see, this is 1 into 1, 1. So this is minus 2. So 2 into 0, this value is 0. So this is minus 2. So if I multiply, so this will be minus 4 and this is minus 2. So this value is plus 2. Minus 2 into 3, this is minus 6 and this value is 4. Clear? So this is 1 into 1 is 1. So this is 2 into 1, 2, and 3 into 0 is 0. So 1 into minus 2 is minus 2, 2 2s are 4 and this value is minus 3. So this is 1 into 2, the value here is 2, 2 3s are 6 and this is 3 into 2 is again 6. 0 into 1 is 0 and the next one, this is minus 1 and this value is plus 1. So this value is 0 and this value is minus 2 and this value is again minus 2. So this value is 0 and this value is minus 3 and this value is plus 4. Clear? And our A square value is, see, this value is minus 1. So A square value is equal to, the value here is minus 1. So this is minus 4. So this is minus 4, the value here is minus 8 and this is plus 6 and minus 6. So if we can cancel these, so this is 0 and this value is a 3 here and this value 4 minus 5. So the value here is plus 4 and minus 5 and this is 12 plus 2, the value here is 14 and this is minus 1 and this value is minus 4 and clear, this value is 1. So we got A square value. So after getting A square value, we need A cube value. For finding an A cube value, what we have to do? So for finding A cube, again we have to multiply. So this value is A square into A. So A square into A. So A cube value I am finding here. So this is going to become, so A cube, what is our A square? Just now we found that is minus 1 minus 8, 0. This is 3 minus 1, this value is 14. This is minus 1 minus 4, 1 into the value here is A. So A is very clear as this is 1 minus 2, 2. This is 1, 2, 3 and this is 0 minus 1, 2. And now for multiplication, see here, these two are the sleeping lines and these two are the standing lines. I am going to multiply A cube. See here, A cube value is equal to, see, this is minus 1 into minus plus 1. This is minus 1. So this value is minus 8. This value is plus 0. So this is minus into minus plus 2 and this value is minus 16 and this value is 0. So this is minus 2 and this value is minus 24 and this value is 0. So this is 3 ones are 3 and this is minus 1 and this value is plus 0. So this is minus 6, this is minus 2 and this value is minus 14. So this value is a 6 and this value is minus 3 and this value is plus 28. So this value is minus 1, this is minus 4 plus 0. So this value is 2 and this value is minus 8 and this value is this is minus 1. So if you see, this is minus 2 and this value is minus 12 and this value is plus 2. Clear? And see, our a cube value is, our a cube value will be minus 1 minus 8 is minus 9 and this value is minus 14. So here this is minus 14, this value is minus 26 and see here this value is 2 and this is minus 8 and minus 14. This is minus 22 and this is 3. 31. So 3, 21, 38 and this value is minus 5 and this is minus 9. So minus 9 plus 2 minus 7 and so if I cancel these two, the value here is plus 2. So we got the values of a square as well as a cube. So here if I substitute, so what is our a value here? First of all, our a value is clear as, so a value is nothing but 1 minus 2, 2. This is 1, 2, 3 and this is 0, minus 1, 2. So what is our a square value? See, let me show you. Our a square value is this one as minus 1. So this is minus 1 minus 8, 0. This value is 3 minus 1, 14 and this is minus 1 minus 4, 1 and our a cube value is also ready. So let me show you this one. A cube value is nothing but minus 9 minus 14 minus 26. This is 2 minus 22. This value is 31 and this value is minus 5 minus 7. This value is minus 12. Clear? And now what is our characteristic equation? So this is our characteristic equation. So now we have to check whether it satisfies the equation or not. So here consider a cube minus 5a square plus 13a minus 9 into I. So here every value I am replacing with a here. So in place of a cube I am writing this value. So this is minus 9. See here. So this value is minus 9 minus 14 minus 26. So this value is 2 minus 22 and this value is 31. So this value is minus 5 minus 7. This value is minus 12 and this is minus 5 times of a square. A square value is nothing but minus 1 minus 8, 0. So this is 3 minus 1. This value is 14. This is minus 1 minus 4, 1. Clear? So this value is 13 times of a value here is this one. This is 1 minus 2, 2. This is 1, 2, 3 and this is 0 minus 1, 2. Clear? This is minus 9 times of, this is 1, 0, 0, 0, 1, 0. This is 0, 0, 1. Now we have to check whether this satisfies the equation or not. See here, first of all, what is our a cube? So this is our a cube. I am going to multiply with 5 inside and 13 inside. So here this is going to become, this is minus 9 minus 14 minus 26. This is 2 minus 22. This value is 31. So this is minus 5 minus 7 minus 12. Clear? So if I send minus inside, so this is minus 5 minus 40, 0 and this is 5 3s are 15 minus 5 and this is 70 and this is minus 5 minus 20 and into 5. And here, so if I multiply with 13, so 13 ones are 13, 13 twos are minus 26 and this value is plus 26. So this value is 13, 26, this is 39, 13 into 0. So this value is minus 13 and next one is this one. So if I multiply with 9, so this is 9, 0, 0, 0, 9, 0 and this is 0, 0, 9. Clear? And now I am bringing to one matrix. So this is minus 9, minus into minus, this is plus 5 and this value is plus 13 and this is minus 9. Clear? And this is minus 14. See here, minus 14, minus into minus plus 40 and this is minus 26. Minus 26 and this is minus 0. And the next one is, this is minus 26 minus 0. And this value is plus 26 plus 0. Clear? And next thing here is, this is 2 and this is minus 15 and this value is plus 15. This is minus 0. This is minus 22. This is minus into minus. This is plus 5 and this value is 26. This is minus 9. So this value is 31. This value is minus 70 plus this value is 39 minus 0. And this is minus 5 minus of minus plus 5 plus 0 and this is minus 0. And the next one is this is minus 7 minus of minus plus 20 and this value here is minus 13 and this is minus 0. And next one is minus 12 minus 5. So this is minus 5 and this is plus 26. This value is minus 9. Clear? So everything is ready here. Minus 9 plus 5 plus 13 minus 9. This is minus 14 minus of minus plus 40. So this is minus 26 0 and this is minus 26 minus 0 plus 26 0. So here, so let me add each and every value here. So this is going to become, this is minus 18 and plus 18. So here this value is, this is 18 minus the value here is 18. So if you consider this is plus 40, this is minus 40. So if you see this is minus 26 plus 26. So this is 15. So this is 15 minus 15. So here this value is 31. So this value is 31 minus 31. So this is 31 plus 39. The value here is 70 minus 70. So this is minus 5 plus 5. So this value is 20 minus 20. So this value is 17 minus 26. So this is minus 26 and this is plus 26. So if you observe each and every value, so this is plus and minus, this is plus and minus, plus and minus, we can cancel each and every, or else we can subtract the value here is going to become 0 0 0. So this is 0 0 0 0 0 0, this is 0 0 0. So here what we have considered, so we have considered as a cube. So this value is a cube. So this value is a cube minus this is 5a square. So the value here is 13a minus 9i. So we got the value as 0. So here from this we can state that every square matrix satisfies its characteristic equation. See here, every square matrix satisfies its characteristic equation. Hence, Cayley's-Hamilton theorem. So here, Cayley's-Hamilton theorem is verified. So here, Cayley-Hamilton theorem is verified. So next thing is verified. So if every square matrix satisfies its characteristic equation, we can conclude that Cayley-Hamilton theorem is verified. And next thing here is we have to find A inverse. See here. For finding A inverse, so just now we got this is A cube minus this is 5A square plus 13A minus 9A, we got the value as 0. So according to the Cayley-Hamilton theorem, so here if you observe here from on both sides I am going to multiply with A inverse. See here I am multiplying with A inverse and see what happens here. So this is going to become, if I multiply, so this is going to become A square. So if I multiply, this is 5 times of A. So this is 13. A inverse into A inverse into A. So this is 9 into this value is A inverse, this value is 0. So I need A inverse value. I am sending this term to other side so that it's going to become a positive one. 9A square value is equal to, this is A square. This is minus 5A plus 13 into I. Clear? So if I substitute, as I got all the values ready here, so A square is ready, A is ready. So let me show you the values here. So A square value is ready, A value is ready. So I am going to substitute. So this is 9A inverse value. So what is our A square value? This is minus 1 minus 8 0. This value is 3 minus 1. This value is 14. This is minus 1 minus 4 1. Minus 5 times of A. A value is, this is 1 minus 2 2. This is 1 2 3 and this is 0 minus 1 2. Clear? Plus 13 times of I means 1 0 0 0 1 0. This is 0 0 1. Clear? And now we are going to find out A inverse. So here 9A inverse value is very easy, as this is minus 1 minus 5. So this value is minus 5 plus 13. And the next one, this is minus 8 and this value is plus 10, and this value, so here the middle one here is 0, and the next one, this value is 0 and this value is minus 10, and value here is 0. So this is 3 and this value is minus 5, and here this value is 0. Clear? This is minus 1 in middle, so this value is minus 10. In the middle the value here is minus 13, and see, this value is 14 and this value is minus 15 and this value is 0. See here, this is minus 1 and this value is minus 0 and this value is 0 again. So this value is minus 4 and this value is plus 5 and this value is 0. So here the last one, this is 1. So this value is minus 10 and this value is plus 13. Clear? So here 9A inverse value here is, this is minus 6 plus 13, the value here is 7. So this value is 2 and this value is minus 10. So this value is minus 2. So minus 14, this value is minus 1. So this is minus 1. So if you observe, so this is minus 1. So this value is plus 1 and this value is 14 minus 10, the value here is 4. Clear? So therefore we got A inverse as 1 by 9 times of, this is 7 2 minus 10, this is minus 2 minus 1 and plus 1. See here there is a mistake. See, if you observe, this is minus 11 plus 13. The value here is 13 minus 11. The value here is plus 2. So this value is going to become plus 2. So this is minus 2 plus 2 minus 1 and this is minus 1, 1 and 4. So here, if you observe this one, as it is so simple, if you follow these steps, first of all, we have to find out the characteristic equation, as the characteristic equation is also very easy, as A minus lambda is equal to 0. So this will be the characteristic equation. In place of lambda, I am going to substitute A. So for that I need A cube, A square, A value. So all the values I have calculated, A square, A cube. So this is A square and A cube. And after substituting, so in the characteristic equation, so I got 0, 0 value. So the characteristic equation is satisfied by the square matrix, and hence Cayley's Hamilton theorem is verified. So after that one, so in the same characteristic equation which is satisfied by A, so I have multiplied with A inverse on both sides, so that I got A inverse here. So here 9A inverse is this one. So I have substituted A square value, A value and I value, and this is our final value, that is A inverse. So this is how we have to satisfy the Cayley-Hamilton theorem, and also we have to find A inverse value, as it is very simple but very important, even though it's very lengthy. Don't think it's a lengthy, as it is very important. Please practice. Definitely you can score more. If you really like, please pass it on to as many friends as you can. That is the greatest help needed to this channel, and even your friends also needed the same. Thank you so much for staying till the end.